In this presentation, we're going to be looking at migrating your project to OpenRoads Designer. There's a couple of preliminary issues that we want to deal with, and the first one is working units. If your project working units are different from those in your ORD workspace, you should be fine. However, it's recommended that you use seed files consistent with your existing project files. This way you won't be mixing DGN working units within the project files themselves. A second issue that you need to be aware of is how features are going to be handled when migrating a V8i project forward. All feature names will be created from the source V8i data. Now, this can create a challenge if you've changed your feature names from V8i to ORD, as you will have to deal with what we call unsupported features. In other words, these are features that existed in your V8i project or workspace, but no longer exist in the ORD workspace because they've been renamed. Now, if you've only changed a few features, the manual work necessary to update those features is probably going to be minimal. However, if you've changed a lot of feature names, then the work, of course, could be significant. In this scenario, one option to consider would be to create a custom workspace that supports the older feature names. Now, in this presentation, we'll be looking specifically at a GEOPAK project that uses the OpenRoads technology. Now, the first thing you want to do is run reports in your current version. These can be geometry reports, super reports, corridor, and drainage reports. We'll use these at the end of our migration in order to validate that all our data has come forward properly. Before moving on, we need to consider the use of the ITL remapper utility. This utility can be found under the Bentley Communities under Migration Utilities, and you'll see here the template library ITL remapper. This utility is used to convert older feature names in an ITL to the new feature names contained in the ORD workspace.
In this video, we're going to map our feature definitions from the old template library to the new template library in OpenRoads Designer. We're going to use the Migration Utilities ITL feature mapping tool, and we're going to open up these two CSVs, the point feature mapping and the component feature mapping. In column A, we have the old feature definitions. In column B, we have the OpenRoads Designer feature definitions in both the points and the components. If they happen to match, they will map directly from the old way to the new way. If they don't, we want to make sure we fulfill the appropriate names and save them and get out. Then we'll open up our ITL feature mapper executable. It's going to ask us for the component feature mapping file, so we'll select our CSV. Then we'll then select our point feature mapping file. And then lastly, we'll select our template library. Once we hit process, a log will be created to identify all of the points and components that did not map appropriately. Let's go ahead and take a look at that log and see which ones did not map appropriately. Here we can see we have PR ditch, V-shaped, profile, V, left and right. Let's take a look at our feature mapping CSV to compare. And here we see that they should have been mapped, but because of the quotations in the XML, did not map appropriately. So what we can do is replace all the quotes in this file with this string, end quote, semicolon, and that's how we'll find it in the XML, in the template library. Now we'll open up our ITL with Notepad++ or Notepad or any type of text editing tool, and we'll perform an edit replace with these 3-point feature definitions. We'll save it, we'll close it and get out. Open up our template. First, let's take a look at our original components. We can see that a lot of the feature definitions are white. If they don't have matching names, you'll get this error message that says it's not found in the current design file or in the dgnlib, and they don't have a feature definition assigned. If we didn't want to use the feature mapper tool, we can select each template one by one and apply feature definitions to points in bulk. This also works for components as well. Now let's open up our remapped template library and take a look at the difference. As we can see that all of the feature definitions have mapped appropriately. Depending on the version that we've upgraded our template library from, we may need to add the super elevation flag. We can do this through all of our templates one by clicking on each individual point and checking the super elevation flag. We'll have to do this for every template that has super elevation. Or we can go through each template and apply them in bulk using the apply super elevation to points, selecting all of our points, checkboxing the super elevation flag, and hitting apply. Once we've finished checking everything over, we'll save the template library and close out. And we'll want to rename our old template library to a back file and rename the remapped to our original file name.
Since our project is using OpenRoads technology, we have the option or the ability to use the version checker utility. Now there are a few limitations on this utility, so let me set them out before we see how it works. First, this will not work for an SS3 project, only SS4 and SS10. If you have an SS3 project, you would first need to migrate that to SS4, then you could use version checker. It also has no project-wise integration, so files would need to be exported locally, converted, then taken back into ProjectWise. There's also no support for drainage and utilities, so drainage and utilities would need to be brought forward into OpenRoads Designer using another method. And the super is static. It will be brought forward, but it is what it is. If you need to change that super elevation, you would need to delete it and recreate it. So with that said, let's see how the version checker works. So I've got an SS4 or an SS10 project here that uses OpenRoads technology, and I want to migrate this project forward into one of the Connect versions of our civil products, such as, let's say, OpenRoads or OpenRail. So let's just first take a look at our project. You can see here in the main directory I've got a quarter file, and I've also got a geometry subdirectory, a super elevation subdirectory, as well as a terrain subdirectory. So what I want to do is I want to migrate this entire project as opposed to the files individually. And to do that, we're going to use a program called Version Checker. So I'm going to come over here to my OpenRail Designer directory. Now, this program is included with all of the civil. So I've got an SS4 or an SS10 project here that uses OpenRoads technology, and I want to migrate this project forward into one of the Connect versions of our civil products, such as, let's say, OpenRoads or OpenRail. So let's just first take a look at our project. You can see here in the main directory I've got a quarter file, and I've also got a geometry subdirectory, a super elevation subdirectory, as well as a terrain subdirectory. So what I want to do is I want to migrate this entire project as opposed to the files individually. And to do that, we're going to use a program called Version Checker. So I'm going to come over here to my OpenRail Designer directory. Now, this program is included with all of the civil products, so OpenSite, OpenRoads, OpenRail, or OpenBridge. In my case, I just happen to be running OpenRail, so that's the directory that I'm going to go into. And you can see here there's a version checker.exe. So I'm just going to double click on that, and you get this graphical user interface. Now, version checker can be used for several things. For example, it can be used for product branding. For example, to take an OpenRail file and rebrand it to OpenRoads, or vice versa. It can also be used to look at the schema details, what the schema is on a particular file. But obviously the one that we want to use is we want to do a project upgrade. And so to do this, I'm going to come over, I'm going to do a file open, and I'm going to select the folder. And we'll just come down and select the location of our project. And in my case, it's this project 1329A. Now, when I do that, you'll notice it'll find the corridor file, and it sees everything that's attached to the corridor. You can also come in and look at this upgrade list, which is very useful. Now what this tells us under View Upgrade List, what this tells us is the order that the files are going to be upgraded in. So for example, the corridor references all three of these. The super elevation may only reference these two. So it tries to figure out what order it needs to upgrade these files in. Now once we're satisfied that all our files are there, they're in the order that we want them, we'll just come under Action and we'll do an Upgrade All. So it'll go through our project and it'll do all of our upgrades, and when it's done you'll see an upgrade complete. Now what I want to do is go back over to my project directory, and you can see here at the main root directory, it's created a project 1329a.zip. Now this is basically a backup of all of your SS4 or SS10 files that you started with. So even though it did migrate them or convert them, it created a backup for you in this particular zip file. Okay, so the files that actually exist now in your main or in your folder that you selected have been upgraded to the Connect version. So I'm going to open these with OpenRail, and let's take a look at what we've got. So let's begin by going into our geometry file. Now we will, since this is the first time that we've open this up in OpenRoads Designer, we'll just get the no work set alert, so we'll just select that one. And here is our geometry file. Now let's go ahead and select this. The first thing you see is you get your standard element handlers and everything. You'll also notice over in the properties a couple of things, that it brings whatever the feature definition was in the older version, that if there is a corresponding feature or the same feature exists in OpenRoads Designer or OpenRail or whatever the product may be, it'll get assigned to that. If that feature does not exist in the OpenX product, then it will just be created with whatever it was using in the SS4 or SS10 project. So a couple things I want to point out here. Let's go back over and look at Project Explorer. And I want you to notice that the alignment here, or the center line geometry, came in as linear geometry. It did not come in as an alignment. Now the reason for that should be obvious, is because the alignment category did not exist in those previous versions. So anything that was linear geometry comes in as linear geometry. So we want to change that. We want to upgrade it to an alignment, and we also want to change our feature definition. So I'm just going to come over here under the Set Feature Definition, and I'm going to select alignment, and I'm going to choose a feature under that. I'll just choose Geom Baseline, and we will select that and update it. Okay, now that we've done that, if I come back over and look at the properties, you can see it's now set to Geom Baseline. If I go back to Explorer, you can see it's been converted over to an actual alignment now, which is exactly what we wanted to happen. So if I want to come back now and annotate that, let's just select a drawing scale here. We'll just select 1 inch equals 50. We can annotate this inside of our OpenRoads or OpenRail product. Now, the next thing we want to do is let's go look at our, let's say our terrain. And once again, let's look at the properties for this. You can notice it already had a feature definition assigned, which was existing boundary. That's perfectly okay if that, but we may have renamed we may have renamed our features or changed a few things in OpenRoads. So if we need to, we can just come in here and let's say change this to a different feature definition if we need to. But you can see this has been converted. Everything looks good. Now let's come in here and take a look at our super elevation. And you can see here we don't have a feature definition on that, so I want to go ahead and set that. And you see it was brought in. It recognizes our stations. If we move in here, you can see the different super elevation start and stop locations on our super, and everything looks good there. Lastly, let's go just validate our corridor. So we'll go into our corridor file, and let's just make this a little easier to see here. So we'll just come in here and we will turn on our override symbology, and we'll just turn off our contours there so we can see it a little bit better. Again, you can see everything looks good here. We can come in here and look at our corridor. We can change our feature definition if we need to here. If I wanted to come in and look at my cross sections, you can see we can cut our cross sections here. We can change our scale there. So everything looks pretty good there. This would be where we want to come in, for example, and go look at our corridor objects dialog. And we can see that our super elevation point controls are in there as well. If we had any parametric constraints, any end condition exceptions, you would just want to check those things and make sure they had come through. Now at this point, you may or may not need to regenerate your sheets. This can of course depend on various factors such as where you are in your project and of course how much has changed since you've migrated your project in. If you do need to regenerate your sheets, there are numerous resources available to assist you in sheet production. As we just mentioned, Version Checker does not support drainage and utilities. So you'll need to import your drainage manually. Now you may have used GEOPAK drainage on this project while using OpenRoads technology for everything else. If you have, please refer to the first presentation in our series that deals with GEOPAK projects using non-OpenRoads technology. That will give you two options for manually importing your GEOPAK drainage. If you use SUDA on your SS4 or SS10 project, this video will show you how to bring it forward.
This is the V8i SUDA data that I want to migrate forwards to a Connect Edition product. Now I'm running Power Civil Select Series 10, but this workflow would also work in Select Series 4, and in either of those two versions I've got access to the subsurface utility menu. So the first thing I'm going to do is place a crossing window to select all of those elements, and from the subsurface utility menu I'm going to go to Project, Export, Export Submodel. We'll give the submodel a name, choose a location for it and click Save. And that writes all of the hydraulic properties out to the submodel. Having done that, I'm going to clear the selection set. I've activated a subsurface utility engineering license. So I can go to subsurface utility view flex tables, and I'm going to open up the stormwater nodes flex table from the subsurface utilities engineering tab. I'm then going to edit the columns that are shown and double click on rotation to add that field into the available columns, because I need to supplement the submodel that I exported a moment ago with a bit more information. I've now switched over to the Connect Edition product. I'm running OpenRoads Designer, but it could equally be OpenRail or OpenSite Designer. I'm using the Training and Examples workspace and the Training Imperial work set, but you'll probably have a DOT workspace that you'll be selecting, and that will contain all of the feature definitions and settings. So I'm going to create a new design file, give it a name and a location, and click Save. Then I'm going to select the Drainage and Utilities workflow and go to Tools and Project Defaults to create a utility project in this design file. I can then OK the Options panel. I can then go to the Home ribbon, and under Import Utilities, I can use Import OpenFlow's submodel. The reason I created the utility project first is that that's copied settings from the Subsurface Utilities DGN library into this DGN. So now I'm going to use Import OpenFlow submodel. I'll OK the message, and I'll select the submodel that we created in the VAI product a moment ago and click Open. So that data has been imported. I can fit the view to see it. So the data is now in the design file, but we need to sort out the symbology. The first thing I'll do is turn off the display of the 3D model reference. Then I'll go to the Utilities View ribbon and Flex Tables and open the Stormwater Nodes Flex table from the Subsurface Utilities tab. Now I'm going to flick back to the V8i product, and I'm going to select all the cells in that rotation column and do a Control C. Now I'll go back to OpenRoads Designer, click in the top cell for the rotation field and paste those rotation values in. I'm going to go back to the VAI product one more time, and I'm going to select the cells for the feature definition, and then again go back to OpenRoads Designer, and I'm going to paste those cells in the notes column. I'm just going to tab across into the notes column and do a Control V to paste that data in. I'm then going to right click on the notes column and do a filter custom. And because I right clicked on the notes column, I can double click notes, it's highlighted there, and then I can click equals, refresh the unique values list, and I'm going to select inlet C flat because I want to set the feature definition for all of the nodes in the flex table that include a note of inlet C flat. So you can see now the flex table has been filtered. Then I can go to select in drawing, and that's going to build me a selection set of 15 elements. So now I can go to the Properties tab and scroll down to Feature Definition and choose from the feature definition list the one I want to use. And then that feature definition is applied to the selection set of the nodes. Having done that, I can do a similar thing again in the Subsurface Utilities tab for stormwater conduit, so I can open up that flex table, create a selection set. Before we do that, we'll just clear the existing selection set. Then we'll create a selection set of the conduits. And again, I can specify the feature definition that I want to use for them. And again, that selected feature definition will be applied to the selection set. If we zoom in on the data, we can see how the node feature definitions have been applied and the conduit feature definitions as well, and the conduits are being clipped to the node connection regions. Now I have made one change to the feature definition that I'm using here for the catch basin. I've made the location point in the plan cell coincident with the hydraulic flow line point in the 3D bottom cell, and I'll show you that in a moment. But I could now carry on by creating a selection set for the catchment areas and applying an appropriate feature definition to them. If the ground elevations of the nodes were derived from a terrain model or a surface in the V8i product, then you can achieve the same thing in the Connect Edition product by using a reference of, in this case, the terrain model. And then I can use a selection set again. And then in the properties, scroll down to the elevation reference, click the browse icon and select the reference surface. That will then rule the nodes to that surface. And I can use the same technique to set up the station and offset reference if I have one. So here I've opened the cell file that I'm using in my workspace, and I've opened the model of the bottom 3D cell. Now the purple point there, if I just do a crossing selection, this purple point, the line style 5 construction class graphic, is the location of the hydraulic flow line point. Now what I've done, if I just reference in the plan cell, is that I've made the location point in the plan cell, which is the line style 4 construction class element, coincident with the line style 5 flow line point in the bottom cell, and that will make the coordinates work correctly when the feature definition is applied. And if you do reference one model into another, make sure you remember to delete the reference when you've finished.
The final step in our project migration process is to validate the information that we've brought in. To do this, we'll use the reports that we created in our previous version. Finally, this presentation is meant to be used as a guide. There may very well be questions you have that are not covered in the presentation. If so, please log a support ticket and we'll be glad to help you with any issues you may encounter.